Alright, so my new motherboard is finally here. For some reason, Canada Post decided to leave a $300 package with fragile stickers all over it, just sitting outside on the porch where everyone can see it. It's kind of hard to cut with one hand, especially with a dull knife. The only reason I know it was delivered was because I just happened to check the Canada Post tracking number because, well, eBay's built-in tracking certainly didn't tell me that it had been delivered. It is actually... it's actually not the box for this motherboard, so... hoping I didn't send some random server board. Nope, there it is. There it is. My new Asus, or rather old, Asus P8Z77WS. My dream board years ago, but I've never really had the money to buy anything like it, and I still don't have the money to buy a new one, but now I have this one for my current system, and it will definitely be a good replacement for the garbage ECS motherboard that I'm currently using, which has only 4 SATA ports that are all SATA 2 and only one PCIe 16X slot. So, this isn't a huge issue, because I'll be able to clean it fine, though I'm just kind of disappointed that this was sold by like a fairly reputable sort of computer parts reseller on eBay, because this socket, if you notice anything strange here, right down here by the pins, and right up here in the pins, there is thermal interface material. And I'm not sure what type it is, because I've never really seen anything that looks like it before. I can't tell the type by the color. It's a very dark paste. Like, basically, clean all the TIM off your CPU before even removing it from the socket, because, you know, that can happen. So, socket's basically good as new now. I got all of the TIM out of it. In fact, the person had used so much TIM that I actually had to clean up here on the little hold down latches on the socket cover, or on the CPU cover rather, because there was like TIM pushed under it from the force of mounting a cooler. So there was like TIM all over the inside here, and that's, I guess, how it got in the socket. The guy took his CPU out, didn't check, and closed this cover. And just all the TIM like dripped right into the socket. But I got it cleaned. It's good as new now. No bent pins or anything. Though I came across another problem. If you notice anything strange here. So these slot locks, the PCIe slot locks, they're very easy to open and close, and they don't open far because they don't need to. Well, the person that owned this board apparently thought that it's like an old board where it opens all the way down to the board, because a lot of my older boards do that. The lock goes all the way down and touches the board, and he forced it. So now this lock is just totally broken. I mean, it'll close, but like it's not holding anything in there, and it's like barely holding on by like a thread of plastic. Oh, people. There was no mention of this damage, and that type of damage could not possibly have happened in shipping. Like, it was packed in very nice closed cell foam inside of a motherboard box, and then that motherboard box was packed with bubble wrap inside of a larger box. So there's no way that that damage happened in shipping. Though a pretty cool note, which I will do later in the video, is this. The plastic is still on this, on the chipset heatsink. He never took the plastic off. Alright, so I got my old motherboard removed, this tiny little mini GTX board that has basically no expandability and no upgrade path. And then I have my new board over here. My wonderful Asus WS board. Just look at that comparison side by side. But now I gotta take my cooler and CPU off of that board, and probably also the back plate for the cooler. Oh no, sorry, it uses push pins. Yeah, I was kind of confused for a second. I was like, I don't remember this cooler having a back plate, and this motherboard doesn't have a back plate. But no, it just uses the uses those push pins, so I'll be fine. But anyway, I will do that now, and probably record it. And I will be back in a couple of, well, a few minutes for me, but a couple seconds for you guys. So I did actually end up completing this build, as you can see, with my new motherboard. Unfortunately, I'm having some problems with the board. My first problem was Windows 10 in general. I already knew that was going to be a problem, but I wanted to see if I could get it to work anyway. I have since rolled back to Windows 7 because basically none of the drivers for anything on the board work properly in Windows 10, so I just said screw it and went back. But my biggest problem here is that the DAC on this board over here, it seems to be dead. I thought it was just the drivers in Windows 10 not liking it, but it seems the card is, not the card, the whole, not the whole audio chipset, just the DAC, because the digital outputs, like the Toslink, that still works. It's just the analog stuff, none of it works. So I'm going to try a few more little troubleshooting steps here. So, after what was probably hours of troubleshooting, I have come to the conclusion that the DAC on this motherboard is completely dead. Unfortunately. Thankfully, the eBay seller that originally sold me this board, you know, I kind of told them about it. I was like, yo, dude, you should probably test your stuff before friggin' selling it. Because I asked him and he said he hadn't tested it, which is like the dumbest thing I've ever heard, because he listed it as used and in excellent condition, perfectly working, even though he hadn't used it himself. It was given to him by a friend. But he did refund me like $20 just so I could buy a DAC. I mean, I'm fairly certain the onboard one for this WS board would have been better than like the cheap USB DAC I got, but I mean, we'll see when I get it. But at least it's something.
To start off with some simple specs, my system has 8 gigs of RAM, boots from a 480 gig SP550 SSD from ADATA, has a measly 1 terabyte of mass storage in the form of a single WD green drive, and is all powered by a 1000 watt EVGA G3 power supply. For the horses under the hood, I'm running an i5-3570 non-K overclocked to 4.4 GHz, which we'll touch on later, and a now seemingly ancient, because of more recent GPUs, GTX 660. One of this motherboard's main selling points is its ability to have all 4 of its PCIe 16X physical slots running at the same time at 8X each, despite the CPU only having 16 lanes. It achieves this using a 48-lane PCIe bridge. Specifically, it uses the PUX 8747 made by PLX. In more simple terms, it allows the 16 PCIe lanes from the CPU to communicate with 32 lanes worth of connected PCIe devices on the motherboard. Think USB hub, but much lower latency, much higher bandwidth, and a significantly higher price. The main monitor I use is the surprisingly color accurate HP Pavilion 23CW, and all of this audio is being recorded with my venerable Samsung CO1U. Booting into the UEFI, you can see that I basically have everything where I want it already. Even locked Ivy Bridge CPUs can be overclocked by a factor of 4 on the multiplier and have completely unrestricted base clock overclocking, though this can't be pushed very far. Having my base clock at 104.8 and my turbo multiplier set to 42 across all cores allows my CPU to run at a max boost of 4.4 GHz, a nice improvement over the stock 3.8. This base clock overclock and bumping up my memory to the next multiplier allows me to run my generic 1333 MHz DDR3 at over 1600 MHz while still keeping surprisingly low timings. The CPU, RAM, and chipset are all overvolted a little as well to help with stability. As you can see, the system is totally stable, if a little warm on the CPU. Thankfully, that'll be fixed soon with a cooler upgrade and some more case fans. Anyway, I think that's going to be it for this video. If you didn't like it, then hit that dislike button and leave a comment telling me what you didn't like about it. But if you did like the video, then leave a like, and don't forget to get subscribed if you want to keep up to date on all my latest content. Thank you all for watching, and I'll see you in the next video.